Okay, so you guys ready for the most exciting talk ever? We get to talk about the three most exciting things ever. Samba, Linux, SMB, great protocols. We got some Samba team members here. We get to talk about progress on the most popular network file system, cluster file system. And we get to talk about having fun in Tel Aviv, which is a great city to have these events at. This is the second year we presented last year as well, and it's exciting to have these other Samba guys and to be out here. Okay, so let's talk about progress that was made over the last year in accessing the cloud, in accessing these SMB services, in accessing NAS, and accessing files. So we'll talk. I want to start a little bit with just an overview of Linux, because some of you guys are not Linux developers, or some of you are Linux developers and are curious what's happened. If you were at the summit in Puerto Rico with memory management and file system developers, you'd have a chance to see some really exciting progress that's been made in Linux. As an aside, just what I found most exciting was something called eBPF. For anybody who's a developer here, I was floored. So they gave the keynote at the File System Memory Management Summit. The keynotes were given by tracing people, because every single person in this room who's a developer needs better tracing. So that's a diversion, that's a distraction. But if you guys were at the File System Summit, you'd be seeing that everything's changing about how we monitor. Why is that mount slow to Samba? Why did that fail to NetApp? This is a new world, guys. Linux has expanded. Okay, so what are our goals? We'll talk about that, then we'll go on to the feature status. I'm going to talk a little bit, not just about the kernel client and the user space tools. And by the way, for those of you who got a chance to go to the Storage Developer Conference in Santa Clara, there was an exciting talk that Ronnie Sahlberg gave, Australian developer, about the other user space tools. And something he mentioned, which I thought was fascinating, if you're playing a audio stuff, video stuff in Linux, they have embedded SMB clients, user space libraries that do that. I thought it was very cool. I didn't realize that SMB is everywhere. It's not just probably in all those little devices over there and these little tiny embedded devices. It's also in the media player, in user space. So we're talking about a subset here. A little bit about the user space tools of obviously Volker and others here have done FTP-like tools in user space in Samba. We're not going to talk much about that. I'll talk a little bit about the kernel server, the new kernel server, because I think it's very exciting. But the focus here is on the kernel client and accessing this incredible wealth of storage from the commodity protocol everybody uses, SMB, whether it's a Mac, whether it's Windows, whether it's Linux, whether it's user space, whether it's kernel. We'll also talk about some of the features expected soon, the things Aurelian and I and others are doing upstairs, some configuration suggestions, and then we'll talk about the most important thing of all, the revolution in testing that has happened with the work Paolo and Aurelian and Ronnie have done on the BuildBot. Okay, so a year ago, for you kernel geeks, we were at the 5.0 kernel, Shy Crocodile, and last week we released our evil octopus. It's actually quite hard to find an evil octopus picture, so if you guys have a better one, please let me know. In this one, I think he's stealing the camera from the guy, apparently. In the picture, I didn't quite catch that, but apparently they're stealing a camera there. Okay, so what has been driving activity? If you're at the File System Summit, you'll see, you talk about containers. A lot of talk about the new Mount API, Dave Howell's work there. Completely changes. Mount API in Linux is terrible. You can't return errors very well. Things are getting better there. And for things like NFS or AFS or SMB, you really want a little bit richer API that lets you drill down in the sets of things you can mount. Also, credential management, and once again a Dave Howell's thing, the kernel keyring, that's much improved here. Also, as you probably see from the talks all around us, there's a lot of talk about fabrics and NVMe. Well, there's also a lot of screaming at the File System and Memory Management Summit about these things, right? Because the RDMA guys are mad that we need file systems for lots of things, but in this faster storage world, where requests complete before the request got sent kind of thing, it's like you see things happen so fast that it breaks a lot of apps in strange ways. And also this faster network interfacing. Obviously SMB has supported SMB Direct for a long time, NFS has supported NFS over RDMA, but these faster transports and faster memory on the server side has changed a lot of things. This was recently introduced, IOU ring for better asynchronous I/O. And of course we have this Linux copy problem. This is not like the Windows world where you have this nice robo copy and it does what you expect. Linux has 10 bad tools, right? So there was a lot of, if you want to read the LWN's coverage of this, I gave a talk at the File System Summit on this. Linux, the tools kind of stink for some of this. And how to make that better, how to make the file system take advantage of things file systems can do. And of course, like the last talk, what's changing? Everything's in the cloud. I work in Azure storage. I work on the kernel client, but Azure, Amazon, Google, everything's shifting to the cloud, at least hybrid. And we have to deal with that in the file system in interesting ways. File systems aren't going away. We still need them for everything. Okay, so a year ago, we stated this. Linus gave us the challenge, come up with a name for the 5.0 release. A reason? Well, SMB reborn. If you look at 2 years ago, things were kind of slow. The last 2 years, SMB is the most active network cluster file system out there. Things look exploding in quality. Things are much better. 5.0 was where I really start feeling comfortable. If you're running a 5.0 kernel in SMB, I'm feeling pretty comfortable. These guys running 7-year-old distros, I'm not so comfortable. You really don't want to be using, less secure stuff and buggier. It's the year of SMB, the last 2 years. Okay, File System Summit. Once again at a Sheraton, actually. But here, an amazing group of developers. You probably recognize some of the people in this group. This is the File System and Memory Manager. These are the core guys invited to the File System Summit here in Puerto Rico a year before in Park City. Great group of developers. Linux kernel has an amazing group of people working on file systems. Okay, but we also have this amazing group of Samba people work on the SMB protocol. So this is a picture from the week before the Storage Developer Conference. And you might be able to recognize a few people here. Samba team's amazing. For you trivia buffs, Australia Day was a few days ago, right? I don't know if we have any Australians around. But I just saw something pop on my LinkedIn feed. Who won the Australia Day award? Remember? Tridge. So there was a beautiful post of Tridge getting this award, Australian, the National Australia Day, the Samba inventor. Samba matters, guys. Australia thinks so. So it was very cool to see, this Australia Day thing go to Tridge. Anyway, so let's talk about a summary of file systems. File systems matter in Linux. We're not talking about Windows here, not talking about Macs, it's Linux. Over 6% of the activity, but the most heavily monitored activity outside the memory manager itself. The Linux kernel is huge. I just measured that Saturday, 19 million lines of code. How many of you guys are working on a 19 million line code project? There are more than 60 file systems. When I started working on Linux, the IBM Linux Technology Center, I was the file system architect. I used to give a presentation at the annual Linux conference, how to write a file system in 45 minutes. Maybe I shouldn't have, because now there's more than 60 file systems. But there are only 6. I measured it yesterday. 69% of the activity is these 6 file systems. So there's really only 6 that matter a lot, right? And you know some of these, XFS, ButterFS. I think ext4 was the smallest on that list, number 6. But cifs is by far the most active network file system. They represent almost 5% of the kernel activity, but they're more heavily watched. I'll check in something bad. I'll make a mistake. A day later, I'll get automated email or get email from some guy in Africa who's been running some, very carefully watched. The activity has been very strong over the last 2 years. cifs was probably the number 10 file system 4 or 5 years ago. Now it's the number 3 file system over the last 2 years, each of the last 2 years. It's actually up to about 380 something change sets now over the year. And it's about 55,000 lines of code. So despite our Reliant stuff, we've been trying to trim some stuff, but we do need to do a better job of trimming some of the, maybe get this a little bit smaller. There's a kind of maniacal focus in the kernel on making stuff efficient and small. Okay, so what's the most active? You guys guess properly? BTRFS. You go to the summit, you see the Facebook guys, you can see why. XFS next most active, the file system layer, number 3. Number 4 is cifs after the file system layer. And then, NFS is number, 6 here, then ext4, And you can see these other guys are smaller. And things like the 9P file system, they get a dozen or something, 20 changes. So a lot of the rest just get very little, it's kind of rounding errors. But then I feel embarrassed, because then you look at Samba, the stuff that Ralph and Volker and others here work on. Samba had as many change sets as all of the file system put together. It's 3.5 million lines of code. So the server and tools and all that stuff is, compare with NFS. Samba is 98 times bigger than NFS server. It's hard for me to read, it's hard for me to debug, but it's good for Volker, keeps Volker busy, right? But it has everything. It's like, you need a tool, it's there somewhere. You need some examples, it's there. I was trying to figure out why something failed, and I could have mounted to Azure, right? I work on Azure, right? But I just found it easier to mount to Samba and see what I was doing wrong. I found it, okay? So there's advantage. Samba is 3.5 million lines of code. It's cool. Okay, but there's this cool kernel server thing. I'll talk about this a little bit. So 24,500 lines of code kernel, user space a little bit smaller. They had 2,400 change sets already. That's pretty good. So they gave a presentation at Samba XP. We got to hear a little bit about that. They also gave a presentation at the Storage Developer Conference in Santa Clara. I want to talk a little bit about them because I think it's kind of interesting. Now, one of the things I want to talk about and make you guys think about is our big job here is hard. And it's hard because we live in a world where all of these systems are spread out from the cloud, distributed everywhere. And the guys working on a lot of these features think in terms of local devices. So, in the POSIX API world, you had committees and things went very slowly through the POSIX API, and you had 100 or so syscalls. There are 850 syscalls in Linux. There are 220-something file system syscalls in Linux, and here's ones that were just added in the last 9 months, right? So, if you were here last year, they weren't here last year. And these are just new ones. So we live in a world, guys, where we're not only trying to make storage work for today, we're trying to make storage work with these new async APIs and the new mount APIs and the things that are changing and make that all work really well with guys who don't know how to spell files. They don't know how to spell NFS. They don't know how to spell SMB. So we have a lot of work going forward to optimize our world, or the real world, where storage is distributed, for people who are writing this stuff, who are writing it on their local laptop, right? Who aren't aware of the network world. And we want to do this in a way that it makes it the most secure way. When you mount to Azure, everything's encrypted over SMB. It helps with the reliability, helps with security. We live in a world where attackers are constantly trying to get at this data. It could be virtualized, it could be on-premises, it could be hybrid. And we also have to implement this crazy amount of Linux semantics that's 5 times bigger than what POSIX was, and do it well without waiting 8 years for a new RFC to come out. We don't want to come up with some file system where no progress is made solving these things that are added every year for years. So we have to be able to keep adding these to Samba, to the kernel server, to the kernel client. But I want to talk right now about the good news, what progress we've made recently. I'd love to have done 800 patches last year, but I'm happy enough with 370 or 380. But I'll give some examples from the previous year, what we talked about. Here's mounting to Azure. Snapshots are amazing. This works with everybody's server, right? This is Azure, right? Azure server. I screw up my presentation. I go to a backup of the presentation. It's just a different mount point. It's a different directory. Look how easy this, although it just works, right? Snapshots just work. This is something I talked about last year, so I don't want to dwell on it, but the fact that all of this stuff is just built into SMB and we just take it for granted that, our cloud services will happily back up. You talk to the Mac guys, they have the time machine, right? The time machine working to Azure. You're sitting in Starbucks and it's backing up your presentation automatically and you don't do anything. This is the beauty of network files, right? SMB supports this stuff. You can be sitting in Starbucks and snapshots are going on. The Macs, it does it automatically. So last year we also increased the I/O size default to 8 meg, improved things a little bit, and we moved the default block size up to 1 meg. That helps things like the CP tool to be a little more efficient. So those are things we talked about, some of the examples of last year that we talked about a lot more, but 2 I think are kind of fun to revisit. Now, but what about this year? Well, we have a kernel server. I think that's kind of exciting. So you can go out to the wiki and you can see the Git tree for it, and we'll talk about merging that into Linux Next and all that. But here, while I was waiting for the previous presentation, I added this slide, as the previous speaker was talking. So on my laptop, here's listing amount, and you can see the processes running. Here's the kernel launch processes. Here's the user space. They launch one per interface, and I created a file and directory just while we were waiting for the previous talk. Nothing fancy, but it passes a lot of tests. It's kind of cool. Do we care about this from Samba? Maybe not. But it's great for prototyping, it's great for understanding the protocol, and for embedded devices. So KSMBD, we'll put it in the cifs.d directory so it's easier to find. So you'll have a cifs directory and a cifs.d directory. The cifs.d is the server. That's kind of like NFS and NFSD, the client versus server. It'll be easy to remember. The module itself is KSMBD, and we had to put the K in front of it because Samba's daemon is called SMBD, and it might get confusing if we, having the same name as the Samba daemon. Anyway, it's just something, I'm not working on that per se, but it's just something I thought interesting. So let's talk about some features specific to the client that happened over the last year. One of Aurelian's teammates, Paolo, did some incredible work helping with the global namespace. Remember, this is kind of unique to SMB. AFS has it, but this is by far the most common global namespace. And being able to navigate through DFS from the Linux client much better, and the failover features now work much better, and the security, it's much more stable than it was years ago. So I think people are going to find DFS from Linux usable a lot more, just like people do it all the time in Windows. Cool. The other thing is the security model. So there's two models you see a lot, right? One is where you're using Kerberos or a highly secure authentication protocol, and you're logging on, this guy's logging on as Aurelian, then Volker SSH is in, then Ralph SSH is in, and they're all running with different users. And those users are automatically getting a new secure session under the covers being set up to the server, and the server is doing authentication properly and access control properly. That model, where you have ACLs on the server, that's fine. But there's also a model kind of more like NFS, where the permissions are evaluated on the client, you care about the local UID, you care about the local mode bits. And in that, we call mode for SID. And then there's a kind of a hybrid mode where the mode bits look kind of right. They're based on the ACL, and the server evaluates by the ACL, it's cifs ACL. So cifs ACL, we try to set the ACL to match more or less what the mode bits would be. In mode from SID, we're storing the mode bits opaquely on the server, the same way Windows does. And they're being evaluated on the client, or your pure multi-user mode, where we're probably mounting no perm and just letting the server do all the access checks only here. So we have those three models, and then of course we have ID from SID, so we can store an opaque Unix UID owner in the ACL versus the default owner being set up by the server, whoever that is. The server is deciding who the owner is. So we have two models for owner, one that's opaque to the server, one the server is generating, the kind of Kerberos the Active Directory example, and three security models on the client, where you're evaluating on the client, where you're evaluating on the server, maybe with the Kerberos, your Kerberos identity. So this is more like NFS, this is more like your Active Directory kind of model, and then the one in between. So this is where we're kind of going with, and we've made a lot of progress in the mode from SID. We already had the other two. We're making a lot of progress in mode from SID. It's almost ready. Should be fine in 5.6. Okay, multi-channel. This is exactly what we're working on literally just before we got to this, talking about multi-channel. There's advantages in reliability, having multiple channels. There's also advantages in performance. Right now, I'm only seeing about a 5% advantage in performance, but that's something that Aurelia and I have been discussing, some of the performance problems. There is one known problem we have. We want you to either mount without signing or mount with encryption, because there is a signing-related bug that we're debugging at the moment. It is experimental, but it does have value in some cases. And I suspect by the end of the 5.6 cycle, we'll see significant gains, as we see with Windows, in using multi-channel. Today, you have two things you have to specify in multi-channel. You have to ask for multi-channel, as well as the number of channels. The number of channels, the max channels equals, is eventually going to be removed, but at the moment, we don't know how to guess the optimal number of channels, so we're making the user enter in how many channels. It's a huge performance win. Now, here's an example from yesterday, I believe. Notice each color here. Notice how we're doing round robin. Each color represents a different channel. We're sending each request on a different channel and then going round robin the same thing. So you can see multi-channel working. We are distributing it properly. and going across, taking advantage of the 4 interfaces. This is, Linux client from, I think, a couple days ago. Compounding. One of the things that's fascinating in the cloud world, especially in the Azure world, is that round trips can be kind of expensive. So we want to cut the number, the chattiness of the protocol down. SMB, everything has a handle that's passed. But there's a lot of open, query, close kind of patterns that happen. The progress here has been incredible, and the reason it matters, if you're unzipping a file, you have 11 different VFS calls that come down. That's a lot, in my example. Because Linux is very chatty VFS, it's revalidating each subdirectory in the path. Is the path valid kind of stuff. There's a lot that goes on in an unzip. You think, per file, 11, really? So imagine how much of an advantage it comes when some of these, we've cut from 5 to 2 or 6 to 3, the number of round trips that are sent, by leveraging an SMB feature that the Macs do 10 times better, right? The Macs compound everything, right? And Windows does a pretty good job. Even creating a symlink went down from 11 to 9. So this is a huge thing. Thanks largely to Ronnie, query file information, 6 round trips down to 2. This helps even more when you're going to the cloud world, right? Because the number of network round trips, the latencies go way down. So I can't say enough how much this helps performance, sending these fewer requests, and it's been just leveraging things that are in the protocol, doing a better job implementing the client. So sparse file support. Everything in Linux is sparse by default, most file systems, right? So here's an example using FileFrag. Here you can see cifs supporting it, finding the extents. The CP tool uses this, right? CP uses FIE map. And here you can see an example of the file range coming back from query allocated ranges. So the protocol had support for this. We didn't add it in until the last year or so, the last year. But this is allowing us to support things like FIE map and some of these allocate calls much better, and to pass a lot more of the functional tests, and to work with apps that just expect it to be like a local file system, and to work with sparse files. In this example, it's querying the allocated ranges, and you can see the range being returned because the file is mostly empty, like common. So here's an example test program that's doing FileFrag, set sparse, set zero data, and querying allocated ranges. Here's an example test program that that Ronnie had put together to show some of this off. Okay, the other thing I wanted to talk about is back in the BPF world. So at the File System Summit the year before last, the XFS developers came up to me and the other SMB developers and said, guys, do you know about trace CMD, dynamic tracing? Like, maybe a little bit. Oh, you really ought to be using it. The XFS guys have hundreds, many hundreds of trace points in their code, so they can dynamically turn on trace points for particular customer problems, to check optimizations, to check performance, to debug, without having to do anything invasive. So if you look at the number of events, we quickly added 10 or 15 the File System Summit back in Park City a year and a half ago. Now, or almost 2 years ago, now we're up to 77 trace points. That's still far less than XFS, but these dynamic trace points, basically what happens is a customer comes up with a problem. A user complains about something. We can't reproduce it. We add a trace point for it. We figure it out. We reproduce it because we now have a trace point. We can dynamically check it. Leave the trace point in. The next customer, it's much easier to debug. We had a lot of reconnect problems with dealing with credits. Guess what? We added trace points relating to reconnect and crediting. So I think that it's, we can check the return code coming out of every call. We can see the network return code coming from the SMB server before it gets translated into a POSIX return code. There's a lot of useful things that have been added, and I cannot say enough about this in combination with BPF, dynamic tracing, about how much it's helped our life. The flame graphs and things like that people talk about, the ability to do much more mature tracing, debugging, and analyzing. Okay, this is maybe the most exciting thing of all. How many of you guys would like to triple your performance overnight? Well, that happened at Samba XP, right? So we supported CCM largely because Samba didn't really support GCM, and we thought, oh, what the heck, it's too hard. But some guys were working on this at Samba XP and convinced us to try. So put it together, and Surprise, surprise. Performance went up 80% for read and doubled for write, you know? That's not a bad thing. I ran some test cases at 3.5 times faster. You know, if you have a reasonably fast local disk, you know, it didn't cost anything, right? This was just like using the better encryption algorithm. So adding support for GCM was great. Now in Samba, they also have switched to these TLS libraries, and the Samba presentation earlier talked about that. On the Samba side, not only is GCM faster, but now the GCM libraries they're using are even faster. So what is so cool is that even in Samba, not just to Windows or Macs or anything else, you know, this is staggeringly better to Samba mounts than it was. Double to triple the performance. Nothing changed other than we just support the newer, more mature algorithm. We should have known this, of course. The Windows guys were so excited. It's faster to encrypt than it is to sign, which is really kind of cool, right? It's faster to encrypt by far than it is to packet sign. So why wouldn't you always encrypt now? So it's kind of cool. And you know, on the laptop here, I did a large write test. It was three times faster. You know, writing a large file with DD. And reads were 2.5 times faster on my laptop. Okay, so here's another exciting thing. When you're in the cloud, you might actually have diskless VMs, right? You might have VMs that are network mounted. Well, works now. So the cifs code was added in 5.4, and the networking pieces, the corecs, were added in 5.5. Here's an example of taking SUSE and booting from a diskless system. So kind of cool. So there are times when you know, in the cloud especially, where you might want to have a VM that has no or small disk, boot off an SMB server. Have the rootfs. And here's the instructions for it, setting up the cifs root, the IP config. There's no IPv6 support. Currently it relies on SMB1 because of a mode bit issue that we're addressing. I think in probably 5.7 you'll see the SMB3 support is my guess. Okay, so other things. The protocol for SMB keeps evolving. This isn't like a 7-year wait like between some of the NFS RFCs, right? We have the protocol evolving fairly rapidly. I think at the last Storage Developer Conference they talked about a few things that were added, the compression context and some other things. But load balancers may benefit a lot from the net name context. The Linux client now sends the server name it's trying to connect to as a context on the negotiate protocol, and just like Windows client does now. And that allows your load balancer or whatever to know that it was trying to access, you know, Coke.com instead of Pepsi.com. You know, if you have a server that exports multiple host names on one IP address, different services on the same IP addresses, it allows their load balancers to do smart things. So it's kind of a fun little small thing that was added. We've also added a lot of debugging stuff, pseudo files. So here you can view the open files and then compare that with what your server thinks. We had a lot of customer problems with handle leaks, right? Linux apps that didn't bother to check that they had opened that they'd never bothered to close their files, right? So figuring out the persistent file ID and the flags and the process ID for those files on the mount was useful to correlate with server logs. Some of you guys may find that useful if you have NAS appliances or you know, SMB servers. You can correlate the client stuff with the server stuff and figure out if your application on the client has a bug leaking things. RDMA. There's been a lot of focus on NVMe and fabrics and RDMA. Well, it's been around in SMB Direct a long time, and it has locking and leasing and all the things you'd expect. It's no longer considered experimental as of the 5.3 kernel, and there's a lot of bug fixes. And the automated testing has been improving a lot for RDMA, and Longley's done some good work there. I think at the previous conference we talked about some of the performance numbers, and they really are staggering. I've only done my experiments mostly inside Azure, so running to a Windows VM spun up with RDMA from Linux VMs with RDMA, and it's pretty cool. But anyway, SMB Direct is something I don't use every day in my house, but my gosh, the performance is great. Okay, so 420, there were some significant RDMA improvements. This is stuff we talked about the last time, so I'll skip quickly through. And then you saw the requested R size and W size went from 1 meg to 4 meg. We also added a pass-through ioctl that allowed us to extend user space tools to do more useful things for backup and systems management and restoring things and migration. In 5.0, we now request 3.1.1 by default. 5.0 is kind of my minimum where I start feeling super excited about it. The DFS failover we talked about was added there. And then we can reconnect if the IP address changes. One of the things we ran into a lot with some of these appliances is that people they take down and bring back up their server. The host name was the same, but the IP address would change, and so our client would just hang trying to reconnect, right? Because the IP address of the server changed. Where Windows, I hope Mac too, but Windows would, figure out that the IP address changed and go connect to the new one. So you wouldn't lose any data when you reconnect now because you've got persistent handles, you've got all of the reconnect facilities built into the protocol, but we're now actually checking to see that the IP address changed. So this has been helping some migration scenarios, for example. This ability to reconnect if the IP address changes is a side effect of the DFS changes we talk about. The performance for get and set etc. improved with the compounding, and there were a lot of critical bug fixes dealing with large file copy and reconnect that we found out as SMB3 was started to be used in higher performance workloads. In 5.1 we extended this pass-through capability to allow more, because we had more requirements from user space tools trying to leverage this. We also expanded the support for fallocate. Also, if you want to specifically request persistent or resilient handles and set the timeout on mount, we added that capability. Some special file handling was improved. We added a lot more dynamic trace points. And we also allow caching the root file handle because Linux is very chatty. Being able to cache the root file handle information with the directory release meant that we didn't have to keep re-querying the root directory every second to see what its attributes were. Is the root directory still valid? We need to extend this to directory releases across more subdirectories, though, to improve performance even more. Now, the build bot around this time really helped a lot. I'll get back to the build bot. So in 5.2, the sparse file supporting seek whole and seek data, important for a lot of workloads, the zero range fallocate call, and now we can send info in the pass-through. So this allowed even more user space utilities to leverage this pass-through ioctl feature. Okay, going to 5.3, little things help. Open, we were able to cut from 3 down to 2 round trips for a file open. That's a big deal. That, in my test, typical server, cut about 10% of the performance of a metadata workload, right there, 10% faster. Trying to leverage SMB features. They're already there. Copy file range now supports cross-file copy. I think cross-share copy. I think Amir was around somewhere. There you are. Thank you. So this was brought up a lot in the Kernel File System Summit as well. It's very common to want to migrate from this share on your storage device to this share on your storage device. It's much easier. SMB Direct no longer experimental, and the net name context we talked about. Symlinks in Windows are often stored as reparse points. We typically default to the Mac style, the Minchel French symlinks that are stored as a file with a special size and signature. But there are many options for storing symlinks. That support was added. This GCM crypto by far is the biggest thing, though. Tripling the performance in that example I was just trying earlier. 2.5 times faster for read. You want to be always encrypting when GCM is available on your server, and it is on Windows and NetApp and these others. Okay, 5.4, we can now boot. Thank you, Paolo. Mode from SID, this thing I talked about where we store the mode bits in a special ACE that's unenforced by the server, but allows the client to accurately reflect the mode bits, now available. We also, decryption can be CPU intensive even with GCM, and being able to parallelize that can be optionally done with setting eSize equals, so that launches a worker thread to do the decryption. This might be particularly helpful if decryption is slow on your processor. But it allows you to set the size by which if you have a large read coming in, instead of waiting 8 milliseconds for some, slow decryption in your hardware, you can offload it to a different worker thread and allow other network traffic to continue on your socket, rather than having to do the decryption on the same thing that's doing the socket reads. We found a lot of cases where people I want to disable leases because my appliance is having some scalability problems or specific narrow things, so we added various new mount options. Also, there are cases where the server requests signing, but you're not going to bother validating it. So you can turn off validation on the client. You're still sending it to the signing that the signing cost you to, on the client, evaluate that the signature was valid. You can do sign loosely. Cache equals read-only, cache equals single client allows us to avoid some of the AC timeout configuration settings and assume that the metadata hasn't changed on the file because we're the only client using it. This can help performance in cases where you don't want to be setting AC timeout to a higher value and you know that you're the only guy using it, because we cache only 1 second metadata. And unlike Windows, we don't cache a file after close. Windows often defers closing a file so it can hold on to its metadata longer. What happens a lot is we open, close a lot in Linux. And if it's all you're doing is querying attributes, then this can significantly help. Displaying the max requests in flight has helped a lot with debugging. And then something incredibly helpful, Ronnie and Aurelian and others work a lot on Wireshark. I use Wireshark every day. Wireshark or network analysis tools are critical. But one of the problems is we want to be encrypting by default. Many servers like Azure default to everything being encrypted in the SMB world. Encryption is now fast, right? So, but how do you look at a network trace if it's encrypted? Well, now we have a user space utility as root. You can dump out the keys. And Aurelian last year had added the code to Wireshark to allow you to insert the keys that we dump out here. It's a property. Click, cut and paste, and you can now see the decrypted trace. So we dump out the keys. Aurelian added the code in Wireshark, so you can now see your decrypted trace. It's a very helpful thing, something that people use every day. The ability to get these. Before you'd have to build the module where it unsafely dumped them to kernel logs visible to people. Here it's root only can get at them, and there's an SMB thing, SMB info keys. In 5.5 we added support for whole file lock, the BSD style file lock. We added multi-channel support, thank you Aurelian. One of the things that I think is surprisingly helpful is on close in SMB, you can request the attributes at close time, and in many cases, servers defer updating the M time, defer updating attributes until close actually occurs. So what this allows us to do is cache everything for a second, the metadata after close. So this was a useful thing, this performance optimization. Also, the network pieces, the network dependencies of booting from cifs were added into the network tree. We also cut redir traffic. We cut redir traffic quite a bit by using compounding in redir, and then there was a performance optimization that Paolo did on reparse points in large directories. Okay, so let me finish up here. We got some things we're working on for tomorrow and the day after. I think they're extremely exciting, and I think that these are things that we'd love to get some feedback on. The user space tools, and I want to finish with a really good example. We are testing so many different server targets. Kernel server, Azure, Windows, experimental POSIX, all different server types in our automated testing now. Before we send stuff upstream to Linux, we're trying to focus on this. So any improvements you guys can help here, more tests are good. And this is a big focus, right? Make sure that this commodity protocol, the SMB protocol used everywhere in everybody's appliances, is the most stable protocol to get at any type of storage in the cloud or local. And these testing improvements are critical. We're doing a great job, but we just need to keep adding one fix at a time. Okay, well thank you guys for your attention and time, and look forward to getting some feedback, hopefully in the test event upstairs.